continue this discussion about power and significance levels, and also why we care about that stuff, because remember, a lot of this is, when we talk about statistics, it's about us answering questions and being able to quantify those results in such a way that we can trust them. It's not just enough that we say, hey, it looks true. It might be a lot more in depth or important that we pay attention a little bit better than that. So how can we quantify this better? And that's what these questions are about. Now, as you start to get better at statistics, you start to develop a better intuition and saying, oh, well, it looks like this, and then you can go through and run the statistics and you can be surprised or happy with the outcome, right? But it doesn't necessarily mean that it's honestly true. So we do want to talk about and deal with, can we make this honestly and accurate? How far can we get with the data in that respect? So now is the time we talk about some of the other pieces of that. How often do we know we're wrong? Can we predict that even? And yes, to a degree, we can predict when we think we might be wrong. We have something called a type 1 error. A type 1 error is this idea that we reject H naught when H naught is actually true. Okay? So it's the idea of rejecting H naught when H naught is true. The probability of that occurring is sigma. Okay? Or not sigma, I'm sorry, is alpha, is our significance level. Okay? So let's just say that we set our significance level to p.05, which is our default significance level when we do hypothesis testing. And the idea there is this tells us how often, what's the probability of us rejecting H naught wrongly, which is 0.05. So 5% of the time we're going to falsely reject H naught. Now, some people say, oh, that's pretty high. It's like, how can we actually trust that? Because then you got to remember, though, as we're talking about probability, and the sheer nature of probabilities that we're assuming randomness. So it doesn't mean that 5 out of 100 times we're going to be wrong. What it means is the probability of us being wrong is 5 out of 100. It doesn't mean that that is actually what's going to occur. It just tells us this is the probability. So this is a fairly low probability. Another way to look at this is if you were to bet money, would you bet money that you're going to win 5% of the time? I wouldn't. What if I said that you're going to lose money only 5% of the time? Well, some people would say, oh, well, that seems like a pretty good bet, because the other idea is that you would win 95% of the time. That sounds like a pretty good bet. So that's what we're going with here, is that the probability of a type 1 error, the probability that we're going to falsely reject H naught is 0.05, or the alpha value, our significance. Then we have this other thing called a type 2 error, which means that we accept H naught wrongly, meaning the alternative is true, but we failed to reject H naught. And this happens as well. And the probability of that occurring, the probability of type 2 error is 1 minus the power. So in another video, we talked about how to determine power, and it's a fairly straightforward process. There's actually a lot of software out there that will do that for you based upon the sample size and the alpha value that you're looking at. And you have this power value in there, and you're wondering, well, what's the probability that I'm going to reject H naught when H naught is actually true? What's the probability that I'm going to accept H naught when H naught is actually wrong? Right? So type 2 is this idea that we accept it when it's wrong. Type 1 is when we reject it when it's true. There's this little table, and the idea here is that we would have H naught, HA, right? Okay? And this is saying that they're true, right? H naught is true. HA is true, right? And we, over here, we say we reject H naught. Here we're saying we fail to reject H naught, right? Okay, those are the two scenarios, and we say we fail to reject. We don't say we accept, but we fail to reject H naught. We reject H naught, and this is when they're actually true. So if we reject H naught, it's actually true. This is a type 1 error. We reject H naught, and HA is true. Then we were correct, right? We failed to reject H naught, and H naught is indeed true. So guess what? We were correct. Correct conclusion. we fail to reject H naught when HA is true. So that means that this would be a type 2 error. So those are the scenarios. So we have these two blocks here that actually tell us we're going to be we're going to be correct 2 out of those 4 blocks. Now this is the thing though. If your value for n is high enough so that your power is high enough and your alpha value is low enough, you're talking about T1 being 0.05, and you're talking about T2 being 0.1, maybe, right? That'd be corresponding with a two-tailed test at 0.05. We'd expect the power to be 0.1. So we're talking about these other things occurring most of the time. These other two values are going to be very, very high. So we're talking about the probability that we actually make a mistake. That'd be 0.05 times 0.1, right? 0.05 times 0.01, not 0.01, I'm saying just 0.1, right? Which gives us 0.005 that we've made an error. And this is extraordinarily low. This is 5 thousandths of a probability that we're actually going to be wrong in those instances. Or another way to look at this is 0.5% of the time, which is really low. And that's why these tests are useful for us to look at, because if we look at this, how often are we going to be wrong? There it is right there. Okay, this is how often we're going to be wrong. And then that means that the other time we're going to be right 99.5% of the time, if we want to look at it from that other perspective. All right. I hope this was useful. Please reach out with questions, comments. Let me know if you need more. I'm happy to re-explain other parts and pieces or go into more detail. This is mostly just an overview about type 1 and type 2 error and a little bit of brief explanation of how to figure them. Take care.